My name is Vincent Legstraight. I am the creator of Metaspex. Today, I'd like to talk about a typical case study, the development of a backend for a customer. The name of that customer is Venu. Venu is a B2C and B2B event organization platform with a special focus on social and inspirational features. With Venu, you can organize private or public events, send invites, manage bookings, search for events around you, or receive news about events you might want to attend. Venu owners are active participants of the platform with features of their own. As an event organizer or participant, you use the Venu app downloaded from the Apple or the Google App Stores. The application is fairly big, with 291 complex web services, some quite sophisticated, with map search and multiple criteria, which are difficult to build efficiently with a conventional approach. It even contains a messaging application and subtle role management. In terms of distribution of responsibilities, we did all the backend for Venu, and Venu people worked on the app and the user experience. We are going to concentrate on the technical setup and how the solution was put together. The process we followed has been explained by Venu people themselves in another video. Take a look at that other video if you are interested. We started from the Metaspex framework. The Metaspex framework is a product that we market directly to people who want to develop any kind of backend, whether running at the edge, in a private data center, or in the cloud, in a $15 Raspberry Pi Zero, or in the largest public cloud machines. The Metaspex framework can be used directly by our customers on their own machines to build internal or commercial applications. We also provide professional services using the framework ourselves to deliver engagements with customers. This is what we did for Venu. The Metaspex framework used for Venu is version 2.3.1. It is a substantial piece of software made of approximately 300,000 lines of code. That code is mostly C++ templates our team engineered. It is like the C++ standard template library, except bigger and facilitating online or offline business applications engineering. We have listed a few of these constructs on the diagram. The actual list is much larger, allowing to pick and choose abstractions to build any kind of business application backend, down to specific web services of any kind. We can also build batch application with the Metaspex framework. In spite of its large size, the concepts inside the Metaspex framework are all new and original. We are not going to dwell too long on the portfolio of reusable components, but suffice to say that it contains everything you need to build any kind of business application from scratch. You can also reuse a multitude of ready-made components as ontology bits, as or within services payload. For instance, ISO-compliant addresses, HTML5 compatible geolocations, time series, and everything you need to enforce and manage identity and access management. More than 200 ready-made web services are offered to integrate in your application. The number of reusable constructs, bits of ontology and payloads, and built-in web services grows every day, making building high-quality applications faster and faster on top of Metaspex's natural high productivity. Working with Venu, we wrote the specification of their backend using Metaspex constructs. One person spent less than 3 weeks gathering and converting the business and technical requirements into a Metaspex specification. That specification is made of textual code, and it is also the technical documentation of the backend. The 291 web services and the data model for Venu are completely expressed in 4,600 lines of code. The data model itself is very thorough. It goes far beyond conventional descriptive capabilities. We call it an ontology, to acknowledge the finesse it contains to capture the Venu domain knowledge. It is a word coming from AI. Ontologies are used for domain knowledge acquisition. The Venu source code makes extensive use of the templates listed here in the Metaspex box, plus many others. The 4,600 lines of Venu specification are only the emerging part of the iceberg, the bulk of it lying into the 300,000 lines of the Metaspex framework C++ code. Note that we have tried to show each box size representing its relative bulk. By comparison, the 300,000 lines of code in Metaspex are comparable to the amount of source code in a database server like Couchbase or MongoDB. In the case of Venu, they sit on top of Couchbase, a NoSQL database. Metaspex complements Couchbase with graph and relational databases' advanced features. These 4,600 lines of code are a true specification that describes the what and not the how. If you looked at that specification, and we'll be happy to show it to you should you be curious, you will see no trace of SQL or query language, no database API of any sort, no manipulation of JSON structures, no network-related code like HTTP, HTTPS, and no memory management of any kind. Looking at it, you would see the definition of an ontology, expressing how data are interrelated, and a high-level description of processes that end up appearing as web services, accepting JSON payloads and making JSON replies. What did we do with that specification? We did not use it to generate any code. Instead, we took the Metaspex framework, added the Venu specification, entered that in an off-the-shelf GNU's GCC compiler, and let it generate the code and produce the binary for the backend. The GCC compiler not only produces the binary, but also validates the specification. It won't let it compile if it is not properly formed. This cuts testing drastically. In Venu's case, we did not need to use any complex architecture using microservices. We have nothing against microservices, as Metaspex can generate hundreds of them if necessary, but the complexity they bring was not necessary here. A single 66 megabytes binary contains all the 291 web services needed by Venu. The 66 megs binary contains all the Venu backend and also the Metaspex runtime. The backend contains everything for the Venu application. It makes no use of external systems. Map search, messaging between users, check-in into an event, sending emails, texts, and making in-app notifications is contained entirely in the small 66 megabytes binary. This is difficult to believe, but a 66 megs binary is the size of a standard HTML page containing a few images. Yet, everything is in it, and it is loaded only once in the memory of the machine where it is installed. Technically, that binary is called a module. It runs inside a web server. We support Nginx and Apache. In the case of Venu, they chose Nginx. Not only it is small, but it is also very fast. Venu web services run in a handful of milliseconds of real time, including the database. Some of the web services run in a handful of microseconds. The backend scales both vertically and horizontally. You can configure it to use 128 cores on the machine it runs on. This configuration is made with the web server. Just put 128 on one line of the Nginx configuration file, and you immediately leverage the power of 128 cores. You can also use as many machines as needed with a load balancer in front. As we do not use any garbage collector, memory consumption is very small and scalability is essentially linear. In the case of Venu, with thousands of active users and 5 transactions per second, the backend needs a tiny fraction of a single core. By tiny, we mean a few percent. Venu is currently running in AWS on one of the smallest machines available in the EC2 offering. It is using only a small fraction of it. The database Venu chose is Couchbase. All apps running on iOS or Android devices connect directly to a load balancer in AWS that carries app web services calls from all devices to the backend. That load balancer is not even necessary as only a fraction of one core is used. Since Venu went to production a couple of years ago, just a handful of bugs have been found, all fixed within minutes. This is the benefit of writing a specification which is formally validated by a compiler. A number of evolutions were necessary. They never took more than a few hours to implement. So far, the evolution of the ontology never required running a batch program to upgrade existing documents. This might come, but the fact that we have never needed it shows the level of automation offered by Metaspex. So, if you need us to develop your backend or part of it, let us know at info@metaspex.com. If you want to use the Metaspex framework to develop your own applications, commercial or not, just contact us. We'll let you download the framework, work with it, and we'll be there to train you and assist you along the way. In the case of academic research, the framework is free. The implications of what the technology can do are still being explored.